All right, so these are the answers for A, C, and D. So if you want to press pause at this time, press pause, and then you can take a look at what is happening here, okay? But what we do need to go over is we need to continue on, and we're going to do some of these problems that are on this page, okay? I know this is kind of weird because my son is holding the camera and I'm trying to do this, so bear with me. Okay, let's do letter F. So for letter F, if we put the limit, if we put 3 into the equation, obviously that there will be, it appears that you'll have a denominator that's undefined, but we also need to check, okay? So we're going to look at breaking this down a little bit more. So x squared minus 9 is the same as saying x plus 3, x minus 3. So at this point, obviously, there's no whole, right? We can't cross off anything. So, and if I do put 3 in the denominator, that will cancel this out, making this 0. So at this point, this is D and E. Okay. Let's do letter H. Okay. Letter H, we are going to get rid of that numerator by multiplying by the conjugate. So I'm going to say, well, sorry, before I do that, let's multiply by the conjugate, which is 2x plus 5 plus 1 over, oh, too long, 2x plus 5, scratch that, plus 1. Okay, so I'm going to FOIL the top, or in this case, this is a difference of squares. Okay, so if I do that, I'm going to square the first term, which ends up being, sorry, I made a mistake already, which ends up being 2x plus 5, right? If I square these two, it just gets rid of the radical, and then minus 1. Okay, on the bottom, I'm just going to keep it as x plus 2 and the square root of 2x plus 5 plus 1. Okay, so on the top here, we have the limit as x approaches negative 2. On the top will be 2x plus 4. On the bottom will be that. I haven't established the limit yet, so I have to keep that limit there. And I'm not going to write it this way because the readers don't like that. So, okay, and then I'm going to factor. So the limit as x approaches negative 2, I'm going to factor out the 2. This would be 2 times x plus 2, and that will cancel out with one of the items on the bottom. Oops, plus 1. Okay, so I'll have the limit as x approaches negative 2 with 2 on the top and the square root of 2x plus 5 plus 1 on the bottom. So now I can establish that limit by substituting, and I'm going to get 2 over, what is that? 1 plus 1, which will be 2 over 2, which would be 1. Now the reason why I can write it this way is because these are equivalent. Okay, so 2 over 1 plus 1 is the same as 2 over 2 is equal to 1. But the readers don't like you to show that the limit and keep going this way. So just be careful with that. All right. Okay, what I want you to do is try letter I at the moment and see if you can get that answer. Okay, so press pause at this time and you will find to see if you can do letter I. Okay, we're going to move on to the next one. Okay. Let's look at letter K. Letter K. So for letter K, we are going to factor. So let's go ahead and factor the top and the bottom. So the limit as x approaches 2 from the right. The top will be factored out as 3x plus 1, x plus 2, all over x plus 2, x minus 2. Okay, and this cancels out, so there's a hole at negative 2. Sorry, my kids are laughing. Okay, the limit as x approaches 2 from the right, we are left with, stop it, 3x plus 1, x minus 2. Okay, so here we have to, because this is a rational equation, we have to find out from the right what that would be. So we would test. Okay, so if our x, if we come from the right, that's going to be 2.1. Okay, and then we're going to plug that in. Oh, funny. Okay, so if you put that in there, if I put 2.1 on the top, obviously the numerator is going to be positive. If I put 2.1 on the bottom, that's going to be positive, so therefore this is positive. And so the limit as x approaches 2 from the right of this rational equation is a positive infinity. Okay, so go ahead and do L and M. So press pause at this time so you can do that. Okay, so if you did this correctly, you would have positive infinity. If you did M correctly, you would have negative infinity as your limit. Okay. All right.